Hey there, Mr. Sutton here, bringing you the AB Calculus 3-9 Extra Practice Number 3 solutions on tangent lines and higher order derivatives. On this problem, we're trying to find an equation for the tangent line to this graph at -4, 15. So we need to start by figuring out the slope of the line at this point. We've already got an x and a y value. We just need an m value for our point slope formula. So let's find f prime, and then we'll plug this point into it. So derivative then, that's going to be 8x plus 13. And then plugging the x value, -4, into this. This is going to be -32 plus 13. So that's going to be -19. So now using the point slope formula, we've got y minus the y value 15 equals our slope of -19, parentheses x minus the x value -4, so x plus 4. For this one, we're trying to find the equation of a tangent line for this rational function at the point given here. So I need to get the derivative of this thing at this point so that I can enter a slope into my point slope formula. I've already got a point. I need a slope now. So for f prime, I'm going to have to use the quotient rule on this one. There's no way to really simplify this and use power rule. So let me break out the box and ribbon here. I've got my numerator, x squared minus 4x plus 2, and denominator, 2x minus 1. And their derivatives. So this is going to be 2x minus 4. And over here, the 2x minus 1 derivative is just 2. Now, before I go ahead and plug this all back in and plug this point into it, I'm actually going to plug in the point x equals 2 inside the box here. And then I'll just assemble things back out here. So if I plug 2 into all of these different parts, for this upper left here, I've got 2 squared minus 4 times 2 plus 2, so that's going to be 4 minus 8, which is -4, plus 2, which is -2 when all is said and done. 2x minus 1, if I plug 2 into that, I've got 4 minus 1, which is 3. 2 times 2 minus 4, that's 4 minus 4, which is 0. And 2 here is a constant, so that's going to stay the same. Now plugging it back in, using my ribbon here, I've got 0 times 3 minus -2 times 2. So that would be plus 2 times 2 when all is said and done. And then I'm going to divide by v squared, so 3 squared in this case. So that's 0 plus 4, so that's just 4 over 9. And then I'm going to plug all of this back into point slope. So I'm going to have y minus the y value -2/3, so I can write y plus 2/3 there, equals my slope I just found of 4/9, and then parentheses x minus the x value, which is 2, so x minus 2. For this problem, I want the equation of the tangent line to this cubic function at 2, 14. I'm going to use the point slope formula to get an equation. I have a point already. I just need to find the slope. So I'm just going to take the derivative of this function and plug my point into it. So my derivative, that's going to be 3x squared plus 3. And I'm just plugging in the x value here, so plugging 2 into all of that. I'm going to have 3 times 4, so that's 12, plus 3 is 15. So now I've got y minus the y value 14 equals my slope that I just found, which was 15, times x minus my x value of 2. For this one, I'm trying to figure out the x value or values where this rational function has a horizontal tangent line. So I'm trying to figure out essentially where the derivative, f prime, the slope of this thing, equals 0. So first I need a formula for that slope. For that, I'm going to need the quotient rule, u prime v minus uv prime over v squared. Let me bust out the box and ribbon here so I can organize all of this. So I've got my numerator, x squared minus 3, my denominator, x squared plus 1, and the derivatives, u prime here is going to be 2x, and v prime is also going to be 2x. Same derivatives because those constants are going away. And I'm going to plug in, well, let's see, there's nothing for me to plug in, so I'm actually going to have to multiply this back out. So I've got, let's see here, 2x times x squared plus 1. And then going the other way with the ribbon, I've got x squared minus 3 in a parentheses times 2x. And by the way, it doesn't matter what order I write the multiplication in, but the subtraction, the order does make a big difference. And then the denominator, v squared, so that's going to be x squared plus 1, all of it squared. All right, well, before I set this thing equal to 0, let me simplify it a little bit. I mean, I guess it doesn't really matter when I set it equal to 0, but let me just simplify it. So let me distribute here. I've got 2x cubed plus 2x, and this is going to be minus 2x cubed plus 6x. I can cancel out those 2x cubed, and 2x and 6x gives me 8x. So now I'm just going to set this whole thing equal to 0, and if I'm trying to zero out a fraction, I just need to zero out the numerator. So I've got 8x equals 0 when all is said and done, and that happens at x equals 0. And just as a quick check, if I plug 0 in for x, it looks like I'm not going to get 0 in the denominator. So this is a valid location for a horizontal tangent, and we are done. On this one, I'm trying to figure out x values where this graph has a horizontal tangent. So I'm basically trying to figure out where the derivative equals 0. Let me find the derivative. I'm going to need the quotient rule on this one. So u prime v minus uv prime over v squared. And let me use the box and ribbon to help me with this. So I've got my numerator, 4x, denominator, x squared plus 4, and the derivatives of those things, which are going to be 4 and 2x. Multiplying this back out with the ribbon now, I've got 4 parentheses x squared plus 4 minus 4x times 2x all over this stuff squared, because that's v squared, so x squared plus 4 quantity squared. And let me simplify this a little bit, and then I'll set it equal to 0 when I'm satisfied that I'm not dealing with too much here. So I've got, distributing this, I've got 4x squared plus 16. And then this is going to be, let's see, minus 8x squared. Combining like terms, I've got negative 4x squared plus 16. And just to factor this a little bit, well, actually, I guess I don't really need to factor it at this point. Let me just set this equal to 0 and solve from here. So if I'm trying to zero out a whole fraction, I really just need to zero out the numerator. So this is negative 4x squared plus 16 equals 0 is the actual equation I need to solve. And if I subtract 16 and divide by negative 4, I've got x squared equals 4, which means that x equals plus or minus 2. Now let me just quickly check. If I plug plus or negative 2 back into the equation here, it looks like I'm not going to be zeroing out my denominator also, so that's a good thing. That means these are both valid locations for my horizontal tangents. On this problem, I'm just trying to find f double prime. So I'm going to take the first derivative, and then I'm going to take the derivative of that. First derivative, using the power rule, that's going to be, let's see, 3 times a third cancels out, so this is just x squared for that first term. Next term, 2 times 1/2 cancels, so we just have plus x, 1x. And then finally, derivative of x is just 1. Now I'm going to take the derivative of this first derivative. That will give me the second derivative. So just using the power rule again, that's going to be 2x and then plus 1. For this problem, I'm trying to find the second derivative. Now, I guess I could use quotient rule on this, but that's going to be a real pain to do twice. So let me actually simplify this first, and then I'll start taking derivatives. Dividing everything by x here, I can write this as x plus 4 minus 2x to the negative 1. And now let me take a couple derivatives. So first derivative is just going to be 1, and then the 4 becomes a 0 because it's a constant when I take the derivative. And then this is going to be plus 2x to the negative 2. So that was the first derivative. Now I have to take the second derivative, which is just the derivative of the derivative. So the 1 gets zeroed out here. We're really just taking the derivative then of 2x to the negative 2. That's going to be, using the power rule, that's going to be negative 4x to the negative 3. On this one, I'm trying to take the second derivative of this polynomial. So let me start by taking the first derivative. Using the power rule, we've got 3 times 8/3, that's 8x to the second, minus, this will be 10x to the first. This will just be minus 7, and that 1 gets zeroed out because it's a constant. Now for the second derivative, I'm just taking the derivative of the first derivative. So that's going to be 16x minus 10, and the 7 is gone because that was a constant. So there's my second derivative. To take the second derivative of this problem, well, first I have to figure out how to take the first derivative. I'm going to start by rewriting this with exponents. So this first one I'm going to write as 4x to the 1/2. And this next one is going to be minus 2x to the negative 1/2. And now let me take the first derivative using the power rule. So that's going to be 2x to the negative 1/2, followed by, let's see here, we have negative 1/2 times negative 2. That completely cancels, leaving us with just positive 1x to the negative 3/2. So that was the first derivative. Now I have to take the derivative of this to get the second derivative. So using power rule again, 2 times negative 1/2 is going to be negative 1, x to the negative 3/2. That was my first term. And then this next one, I'm going to have negative 3/2 x to the negative 5/2 if I subtract another one. And there we are. For this problem, I'm trying to take the second derivative of tan of 3x. So let me start with the first derivative. That's going to be secant squared of 3x times a tail of 3. I have to use the chain rule because I have this inner function of 3x. And let me see here. Now I need another derivative. So I'm just going to clean that up ever so slightly and move that 3 out in front. A little bit easier to deal with. Not necessary, but I'm kind of cringe when I see this first version of it. All right, so let's take another derivative now. Derivative of 3 secant squared of 3x. So there's an outer function here. This is a big chain rule. The outer function is squaring. I essentially have 3 times something squared. And then secant is the next function in. So derivative of 3 times something squared is going to be 6 times the something to the first power. So 6 times secant of 3x to the first power times the derivative now of secant of 3x. So that's going to be secant 3x tan of 3x. And then finally, I have to take the derivative of 3, the innermost of these 3 functions. So that's going to just be 3. And if I wanted to, I could simplify it and write 18, I guess, secant squared 3x, tan of 3x, if I really wanted to. But I don't need to. That's just if I want to get all fancy.